Okay, this is a short video to describe transactions and metadata on the Cardano blockchain. Metadata is a new feature on the Cardano blockchain, and I'm going to talk a little bit about what it is, why it can be useful, and how you can use it, how you can post metadata to the blockchain. Okay, so very simple diagram. TX here represents a transaction. On a node, when transactions come in, they pile up and they wait to get added to the blockchain. So when you create a transaction, you submit it to your node, and it sits there until eventually it gets added to a block of transactions, and that block gets added to the blockchain. Now, similarly, you create a transaction, but you also add metadata, and this metadata gets serialized along with the transaction and ends up in a block. And as we know, in a blockchain, each block is dependent on the serialization or the hash of the previous block. And so the metadata now forms a permanent part of the blockchain. So as time goes by, the metadata just stays there in the blockchain. So metadata may or may not be associated with a particular transaction. So in the first example, we'll say you may have a unique invoice number. So you're monitoring your wallet and you're looking at the incoming transactions, and in the metadata of a particular transaction, you see an invoice number that you will recognize as your invoice number, and so you know that that payment is attached to that particular invoice. That's one way to do it. But metadata may not be associated with a particular transaction. So I could create a transaction and I could add metadata David Bowie 5 years, and that's obviously not associated with a particular transaction, but it still obviously gets permanently attested to on the blockchain. Now that's of limited usefulness because really we want to normally attest to larger amounts of data. But it's not practical to have large amounts of data distributed across all the nodes of a public blockchain. It's also not desirable maybe to have that data available and readable across all the nodes of a public blockchain. So the solution that we use for this is we create a unique fingerprint of the data that we want to attest to. So in the case of a document, we would hash that document, and then the document is uniquely represented by this small number of bytes. And then this can be attached to the metadata, which can be attached to the transaction and attested to. And then in the future, if anybody wants to validate that, they take the document, they create the hash. Then if they can find that hash in a transaction on the blockchain, they know that that document existed at that point in time. Now, that's an attestation to a document. But usually or often what we would like to do is also to endorse that document. So in this scenario, you may want to add your signature to say that you endorse this particular document. So a classic, very simple example would be a contract, and you want to attest that two people have signed that contract. So to do that, you need public keys representing the identities of the signers. Now, those public keys might be PGP keys. They might be public keys assigned to a DID from the likes of Atala Prism or elsewhere. They may or may not be first-class citizens on this blockchain. At the moment, they're certainly not, but in the future, they might be. But the point is, you do need a public key that represents your identity. So when you have that, you can take the hash of the document, you can sign that with a private key, and you can attach that signature to the metadata. And this could be the basis for a distributed workflow where you are posting information to the blockchain in hash format, so that only the hash appears on the blockchain, and then you are gathering the signatures from various people representing, we'll say, events in a particular workflow. So I've signed it, you've signed it, this company's signed it, and so on. So that's metadata being used as providing data that's associated with the transaction, and metadata being used as an attestation to the existence of a large volume of data, and then metadata being used as an endorsement for data that exists at that point in time. So then how does this look when you go to set this up, or how do you use it? So first you need a Cardano node. You need a Cardano wallet API. This will expose a HTTP endpoint. And then to use this, you can use it directly from, as a HTTP endpoint, using as a RESTful interface. So you can, use the likes of curl or whatever you're programming, however you make HTTP requests in your programming language. Or you can use the PSG API, which is an API that just wraps this interface to make it easy for Scala and Java developers to get access to the HTTP endpoint. Now, what does the metadata look like? So this is most of the time, especially if you're using this wallet API, you will be posting the metadata in this format, and this is a map using which has to have keys as the key basically, and then has a sort of a self-describing format, string, int, bytes, and so on. You can see that there. And to get more information on exactly how that works, the top link goes directly to the API, which gives you good detail on what the metadata should look like, and is always up to date with each release. The second link is then the Cardano wallet, from where you can download the software itself, either in Docker format or directly, and it gives you the instructions to start a node and to start the connecting wallet, as shown on the previous slide. And then finally there's a link to the PSG Cardano wallet API. So if you're a Java or Scala developer, that's available on Maven, and allows you to facilitates basically easy access to both the wallet and to posting metadata. And then finally, this is the Enterprise Solutions email address. So in the professional services group, we have done a lot of work to do the heavy lifting in terms of, we'll say, wallet monitoring, or exposing these endpoints in various languages. So we would be interested in hearing from enterprises to discuss how we can provide solutions commercially.